So most of the times when we hear of parallel circuit, we are thinking of something like this particular diagram. I think of something like this one, right? Or something like this. Yeah, these are the ones that we know since SHS. So basically, it's like we have a circuit. We have, let's say, a resistor, another resistor. This one communication. Let's say there's the battery. So when I say communication, I mean the arrangement, right? Or it could be something like, yeah, how the second one is, right? These are the ones that we know. So this one here is like this particular one here is like this one turned around, right? Yeah, these are the ones that we know. But clearly, when we look at this particular circuit, like here, when we look at this circuit now, what we can see is that we know that these two are in parallel, right? So if they are in parallel, the features of resistors in parallel or any element in the circuit in parallel is that you can move across them without passing through any other element. So if I start from, let's say, here, right? Let's say this is 1 2 3 4. I can move from 1 to 2 to 3 to 4, right, without passing through any other element aside the resistors themselves. So if I come from here, 1 to 2, 2 to 3, 3 to 4, and then 4 to 1 back, right? I don't pass through any other element aside these two resistors, so we say they are parallel, right? Yeah. And then another thing too again is that when you can pass through them like this and then you don't pass through any other element aside these two resistors. Another thing too is that we say that they are connected at nodes. Okay, you see, generally when we have a circuit like this, you have a circuit like this. See, one resistor, right? This is another resistor. This is the battery, right, or the cell. When I'm moving from this side to this one, you see that they are actually connected directly, right? So one way of writing this whole thing is like these two resistors, because they are in series, it's like one resistor, another resistor, right? So they are in series, right? So even if we join them here like two wires and we join them, we see this is a junction, right? But when we have something like this one, this point 3 and point 2, you see that there are not only two wires connected. There's this wire here, there's this wire here, there's this wire here. So like three wires at a point. So points like this, we call them nodes. A node is a point in the circuit where we have more than two junctions, or more than two wires connected at that particular point in the circuit. So we say it's a node. So you see this one is a junction, this is just a junction, but this is a node because we have 1 2 3, right? Yeah. So then when you look at this, when you come here and look at this particular circuit, now we are focusing on this one. When you look here, you might think this one is a bit weird, but actually it's not that different, right? This is what happens. We have, I'm trying to redraw it, one here. So we have one resistor here, it goes like this, and we have one in the middle like this, and then we have a cell or a battery here, then we have another resistor, right? So can you consider these two to be in series? No, we only say they are in series when they are connected by at a point, like so, like for instance like this one. We have something like this. This one we say they are in series because they are connected at a point, right? You can pass through them without passing through any other element, like this, straightforward. They are connected, and then there are only two wires at this point where they connect, meaning they are in series, right? It could also be something like this, where you have one resistor, there's a branch, and then one resistor, one point, right? You pass through them directly from here, you come here, right? Or vice versa. They are in series, right? And then where they connect, there's no other wire connecting, only these two wires, right? So when you look at these two, we can't see they are in series because at this point at this point we have 1, 2, and then 3 wires, right? So we can't see they are in series. Okay, so then think of it this way: whenever you see something like this, try and then trace the two things that makes it either series or parallel, right? So when you look at this two, you see that we said that to check whether if they are in parallel. So first of all, we know they are not in series, right? To check whether they are parallel, try to move all around them to see if you pass through any other element in the circuit, right? So if I move from, let's say 1, 2, this is where they connect. I think that's a problem, right? Right, 1, 2, 3, 1, right? So it's like from 1 to 2 to 3 and then back to 1, right? So if I move from here to here and then from here to here and I move from this 3 back here, you see that the only element that I pass through is this R1 and R2, right? The rest are just wires. I only pass through these two elements, right? Yeah, so one condition is met. The next condition that should be met is that they are connected at a node. What is a node? A node is a point in the circuit where there are more than 2 wires connected at that point, right? So this is the point. So this is wire 1, this wire 1, wire 2, and then wire 3, right? So therefore we can see that R1 and R2 are parallel, right? And then when we are writing parallel circuit, we don't want to write it alone, so we just write this R1 and we just do this R2, right? Yeah, so if this is R3, what can you say about them? You see, now we know these two are parallel. R1 and R2 are parallel, right? So but when you look at the circuit very well, you see that whenever we combine circuits, so like this one, like this particular one here, see this one here, whenever we have two circuits, let's say RA and then RB, I want to find the result and we just add them, right? So we end up getting one resistance, right, which we can represent as RAB for these two, right? Yeah, for these two. So then you see that when we redraw this whole circuit for this particular one, we end up getting a circuit something like this. You have a battery here, or a cell here, you have these two, and then you have this one, right? So this R1 and R2, you have R1, because they are parallel, write it like this, R2, sorry, no. So we write R1, R2, right? And we know this is R3. This is R3, right? So we want to find the resultant. So we've kind of added these two, R1 and R2, which we're having here, right? And then we want to find the resultant resistance in the circuit. So we know that this R1, R2, which is considered as one resistance, this particular one, is parallel to this, right? Because this is 1, 2, 3, 4. So I move from 1 to 2, 3 to 4, right? So if I move from here 1 to 2, so if I move from 1 to 2, 2 to 3, 3 to 4, and back to 1, I don't move through any other elements aside these two resistors, right? So they are parallel, right? Yeah. And the way we write the resultant of these two is that we know this, we consider this R1, R2 as one resistance, right? So if we want to find the resistance in this whole circuit, it's written like this. Because we consider this as one, put it in bracket, and we say this R1, R2 stroke R2 is parallel to R3. So that's it. Yeah. So when we add in series resistance, like in this one, this RAB in this particular case, this RAB here is equal to this RAB here is equal to RA plus RB, right? That's how it's written. But when it comes to the parallel one, so like R1, R2, so this R1 sorry, R2 is like this. Yeah, in parallel, right? So to find them, we want to find the result of this one. We end up getting what we call RT, right? But the parallel circuit, we have something like this. We have 1 on RT is equal to 1 on R1 plus 1 on R2, right? Yeah. One idea of writing it, because they are just two resistors, write it this way: product over sum, right? So R1 times R2 all over R1 plus R2 is equal to this RT. This one can be quite confusing, because if you remember this formula, and you don't invert it, because we have 1 on RT here. If you don't invert it, you get a different answer, right? So it will be good to consider this. So to find the result of this whole thing here, this is what we do. After you have R, so like RA, RB is equal to RA times RB all over RA plus RB, right? We are using this, so it's actually 2. So the effective resistance R1 R2 is equal to R1 R2 all over R1 plus R2, right? So what we get as an answer, we put it here. We'll get an answer comes here, right? And the result, we come and make it parallel. This is an answer, right? The answer that we get, we can make it parallel to what? R3. So the same thing, which will give us the total resistance, right? Or at times we see effective resistance, or you can also see this sum of the resistance. You get what you get for this. For this is R, so R, so A and S, because that's what we had here, right? Times R3 all on the A and S plus R3. Yes, so that's it.